Hi, ladies and gentlemen. We are looking at notes 2.2, which are on multiplying polynomials, which you already have some experience with. In grade 9, you did multiplying a monomial to a polynomial, and then in grade 10, you did multiplying a binomial by a binomial, which is pretty much just FOILing. And now we're going to learn how to multiply any type of polynomial by any type of polynomial. All right, so let's just do a quick review. If you take a look at this question, it says 4x times the quantity 3x squared minus 5x plus 1. And don't forget, in order to be able to do this kind of a problem, what you need to do is just distribute. Okay, so when I multiply 4x by 3x squared, I get 12x to the power of 3, because remember, when you multiply, you add exponents, okay? Then when you multiply 4x by negative 5x, you get negative 20x to the power of 2, or x squared. And then when you multiply 4x by 1, you get 4x. Okay? And this right here is your final answer because it's in descending order and you have no like terms. Okay, so let's look at what we have in this example right here. 2x minus 1 times the quantity 3x plus 5. Now, if you remember, in grade 10, you learned how to FOIL, and FOIL stands for first, outside, inside, and then last. So essentially what you're going to do is you're going to multiply your first in each set of brackets by each other. So 2x times 3x gives me 6x squared. Then you're going to multiply the outside terms. So you're going to multiply 2x by 5, which gives you 10x. Okay? And then you're going to multiply your inside terms, which is negative 1 times 3x, which is negative 3x. And then you're going to do the last terms. You're going to multiply them together. Negative 1 times 5 is negative 5. And then the last thing you're going to do is you're going to collect like terms, and you end up getting 6x squared plus 7x minus 5, and you've completed your multiplication. Now, one thing I want you guys to realize is what you're doing essentially is you're just taking this 2x and you're multiplying it to the 3x and then again to the 5. So really what you're doing is you're taking 2x and multiplying it by 3x plus 5. So you are distributing. This is still the distributive property. But if you do it with the 2x, because it's in brackets, you also have to do it with the negative 1. So then you're going to multiply negative 1 also by 3x plus 5. So now when I distribute this through, 2x times 3x gives me 6x squared like we got before. 2x times 5 gives me 10x like we got before. Negative 1 times 3x gives me this negative 3x we got. And negative 1 times 5 gives me the negative 5. So then same thing, I get the final answer of 6x squared plus 7x minus 5. Okay? All right, so now I'm wondering how I can apply what I know about distributing polynomials to a new type of problem. So if you look right here, I have 5x minus 1 times negative 2x squared plus 3x minus 4. So essentially, it's the same type of idea. I'm going to take the 5x and I'm going to distribute it to everybody inside of this set of brackets. So times negative 2x squared plus 3x minus 4. Okay, then once I do that to the 5x, I also have to do it to the negative 1. So minus 1 times negative 2x squared plus 3x minus 4. Okay, so now all I have to do is do my actual distributing, and then I will collect like terms and I'll be good to go. So 5x times negative 2x squared is negative 10x cubed. 5x times 3x, remember, will give me 15x to the power of 2. And then 5x times negative 4 is negative 20x. Now when I distribute this negative 1 right here, I end up getting positive 2x squared. Here, this gives me negative 3x, and here, this gives me positive 4. So then, when I collect my like terms, negative 10x cubed isn't like anything, so I'm just going to copy that down. 15x squared is like 2x squared, so I get 17x squared. Negative 20x is like negative 3x, so I get negative 23x. And then the 4 is just going to hang out for the ride, and that's my final answer. All right, so now we're going to find the product using an area model. So right here, I'm going to multiply 32 by 121. When I actually do the calculations, I should end up getting 3,872. So we'll write ourselves a note that it should equal 3,872. But I want to show you how to use an area model to figure this out. So essentially, 32 is just 30 plus 2. Okay? And then 121 is essentially 100 plus 20 plus 1. So what I'm going to do is I'm going to use an area model, and since this is two terms, I will have two sections on my area model going this way, and then here I have three terms, so I'll split this up into three different sections. So I have a 2 by 3 or a 3 by 2, okay? And I'm going to put 30 here, I'm going to put 2 here, I'm going to put 100 here, and then 20 here and 1 here. And now what ends up happening is I have right here in this first box, I've got a 30 by 100 size box. And to find area, I just multiply my length by my width. So 30 times 100 gives me 3,000. Okay? Now this is 30 by 20, so when I multiply 30 by 20, I get 600. This box here has one side is 30, the other side is 1, so when I multiply 30 by 1, this box here has an area of 30. This is 2 by 100, so 2 times 100 is 200. This is 2 by 20, so 2 times 20 is 40. And then this right here is 2 by 1, so 2 times 1 is 2. Okay? Then I'm going to put my quote-unquote like terms together. So I'm going to put my thousands together, my hundreds, my tens, and my ones. So right here, this 3,000 is like nothing else, so I'm going to write 3,000. Here, this 600 is like 200, so I get 800. Here, this 30 is like 40, so I get 70. And then here, I end up getting 2. So when I put it all together, I get my answer of 3,872, just like we got on our calculator. Now, why would we use this? It's not really a good idea to use this for regular numbers that you're multiplying. But once you get into algebra and you've got some variables, it might actually be a nice way to organize your work. So let's go back and take a look at what we did with this question right here. And I'm just going to move this all over right here, and I'm going to apply what we just learned to this type of a question here. So if I have a binomial here, I've got 2 terms. Here I've got 3 terms. So if I have a binomial multiplied by a trinomial, again I'm going to do a 2 by 3. Okay? So my first term in my binomial is 5x, and my second term is -1. So I'll put negative 5x in the first box and -1 in the second box. Here in my trinomial, my first term is -2x squared, my second term is 3x, and my last term is -4. So when I multiply 5x by -2x squared, I get -10x to the power of 3. This box is 5x by 3x, so I get 15x squared when I multiply them. This box is 5x by -4, which is -20x. This box is -1 by -2x squared, which is positive 2x squared. Then I've got a box that's -1 by 3x, so I get -3x. And then here I've got a box that's -1 by -4, which is 4. Now, when I put my like terms together, -10x cubed is like nothing, so I'm still going to get -10x cubed. 15x squared is like 2x squared, and when I put them together, I get 17x squared. -20x is like -3x, so when I put those together, I get -23x. And then here I just have a 4 that's going to hang out for the ride again, like we said before. So this is my final answer. Here's a second way that we can do our multiplication of our polynomials. Okay? All right, I would like to take up one last question with you guys, and then we will be done. So if I asked you to figure out what 5x squared minus 4x plus 3 is when I square it, please make sure that you do not tell me that the answer is just all of these terms inside of here squared. So it's not 25x to the power of 4 minus 16x squared plus 9. That's totally incorrect. We'll never get that as our answer. Just like if we have x plus 2 squared, we won't get x squared plus 4 because we have to FOIL it all out. So essentially right here, what this means is I'm going to take 5x squared minus 4x plus 3, and I'm going to multiply it by itself. And when I do that, I'm going to do it using the area model. So this is a 3 by 3 this time. So what's going to happen is I'm going to have a 3 by 3, and it's going to be a square because all my sides are equal, right? And that's why this is essentially called squared, because you're literally making a square out of it. So I'm going to have 5x squared here, negative 4x here, 3 here. Same thing, 5x squared here, negative 4x here, and 3 here. Now, when I multiply, when I want to figure out what this box is here, I do 5x squared times 5x squared, which is 25x to the power of 4, which is what I got there. Great. Now, when I do 5x squared times negative 4x, that's the length that I have here, 5x squared by negative 4x, I get negative 20x to the power of 3. And then here I've got 5x squared by 3, which is 15x squared. This box right here is 5x squared by negative 4x, so when I multiply them, I get negative 20x cubed. Here I've got a negative 4x by a negative 4x, which is positive 16x squared. And here I've got negative 4x by 3, which is negative 12x. On this box right here, I've got 3 by 5x squared, which is 15x squared. This box here is 3 by negative 4x, which is negative 12x. And this box here is 3 by 3, which is 9. Okay, now I'm going to put together all my like terms, and I will be done with this question. So 25x to the power of 4, there's nothing like it, so I still get 25x to the power of 4. Negative 20x cubed is like negative 20x cubed. And when you put those together, you end up getting negative 40x cubed. Okay, 15x squared is like 16x squared is also like 15x squared. So when I put those together, I end up getting 46x squared. Okay, and then negative 12x is like negative 12x, and when I put those together, I get negative 24x. And finally, this 9 is just my constant. There's nothing to combine it with, so this is my final answer right here. Okay, don't forget, you could have also just distributed the 5x squared to everybody right here, which would give you your first line here. Then you would distribute the negative 4x to everybody, which gives you your second line here. And then you would distribute the 3 to everybody, which gives you your third line right here. It doesn't really matter which way you want to do it. Again, this just gives you kind of like a nice graphical organizer to help you get your right answer. All right, come with questions next time I see you in class. Have a great day.